Hi, guys. All right, so today we're going to do part two of the guided notes. So same as yesterday, if you are at home full remote, you need to open the doc and fill in as we go along. And if you are cohort B, you can use your paper copy that I gave you last week, or you can do the Google Doc. Either is up to you. All right, so we want to determine the effect of a certain fertilizer on the growth of orchids grown in a greenhouse. The materials that are available to you include a greenhouse, 100 orchard plants, water, fertilizer, and soil. You want to know if the orchards will grow best with a weak concentration of fertilizer, a medium concentration of fertilizer, or a high concentration. So today we're going to practice figuring out how to design an experiment to test the concentration of this fertilizer. Okay. So first you need to state your hypothesis. A possible example is, I predict that the orchards will grow best with a medium concentration of fertilizer. Now, your hypothesis is up to you, so please do not copy the possible answer. Okay, now, how will I set up a controlled experiment? Remember, you have 100 plants. Okay, so here's one example. The 100 plants are divided into 4 groups as follows. Group 1, 25 plants will receive plain water. Group 2, 25 plants will receive a weak concentration of fertilizer. Group 3, 25 plants will receive a medium group of fertilizer. And group 4, 25 plants will receive a high concentration of fertilizer. So let's break down our experiment. All plants will be watered daily. Over a period of a month, the plants will be measured to see which one grows the tallest. So let's break down the experiment. What is the control in this group? So the control, remember, is the thing that does not change. So what group do you think will be the control? The control group will be the 25 plants that are receiving the plain water. What is the experimental group in this experiment? The experimental group consists of the 75 plants that are receiving the various concentrations of fertilizer. So please make sure you are filling in your document. We are now starting number G. Okay. So in a controlled experiment, all the variables must be kept constant except for the one variable that has changed. So what variables? I'm sorry, that was E. Okay. We're working on E and F now. What variables must be kept constant in the experiment? Okay. All plants must receive the same amount of fluid each day. All plants are grown in pots of equal size. All plants are grown at the same temperature. All plants receive the same amount of sunlight. Okay. So, what is being changed? The variable being changed is the amount of fertilizer received by each group of plants. After 1 month of measuring the orchards, the following data is obtained. Now we are on part G. The control group grew an average height of 15 centimeters. The weak concentration, or group 2, grew to an average height of 35 centimeters. Group 3, or medium concentration, grew to an average height of 28 centimeters. And group 4, high concentration of fertilizer, grew to an average height of 10 centimeters. So is your hypothesis supported or not supported by the results? We hypothesized that the orchards would grow best with a medium concentration of fertilizer. Is that what our results show? Our results show that which one grew the best. Actually, if you look back, it shows that the weak concentration grew the most. So therefore, the results do not support our hypothesis. So what is your conclusion based on this result? We can conclude that orchards grow best with a weak concentration of fertilizer. At medium to high concentration, plant growth is inhibited, which means that it is slowed down. So now let's look at our analysis questions. Why is it important to have a large sample of size in any experiment? So experiments, it's important to have a large sample of size in order to get a true picture of the results. If it's too small, our results may be inaccurate. Testing large numbers of individuals increase the accuracy of our experiments. Why is it important to repeat the experiment? Experiments should always be repeated to see if you get the same results each time. This gives validity to the test and makes it more accurate. What is the importance of the control? So the control shows what will happen when the experimental factor is emitted. Without the control, there is no basis for comparison, and you would not know if the experimental factor affected the results. How is a theory different from a hypothesis? A hypothesis is your educated guess that is testable through your observations and experiments. A theory is a broad statement that is believed to be true based on many experiments and considerable amounts of data. So why is it so important for a scientist to accurately describe the procedure? We want to make sure that we describe the procedure to allow other scientists to replicate our work. What is the difference between the independent and dependent variables in this experiment? The independent variable is the one that the scientist deliberately changes. We deliberately change the amount of fertilizer each plant was given. The dependent variable is the data we collect during the experiment. In this experiment, we measured the plant growth height. Next question. In a controlled experiment, why must all of the variables except one be kept constant? So if we change several variables, we wouldn't know which variable was responsible for our results. So for example, if the plants got different amounts of sunlight, we wouldn't know if that or the fertilizer affected the plant's growth. Okay, that's all for today. Please make sure you record your answers either on your paper and take a photo and submit, or in the Google Doc and turn it in like that. All right, I'll see you on Thursday. Have a great day.